gonna need for this, if you can gather your straws and your pipe cleaners, that would be great. If you don't have the pipe cleaners, if you have paper clips or some tacky material, Play-Doh, modeling clay, that can be your alternative joint, okay?
And Jasmine, what can people do if they really just don't have the materials on hand today?
Okay, so if you don't have any of the materials, what you could do is observe the modeling, take notes, make drawings, label things, so that when you're able to get the materials, you'll know exactly what to do. So you can just follow along with us and see the process to help you get a little bit more comfortable.
And Jasmine, how many pipe cleaners do folks need right now at this point, if they do have them on hand?
Excellent. So you're going to need 7. 7 for now. And a handful of the pipe cleaners.
7 straws?
7 straws, yes.
Okay, thank you.
You're welcome. All right, so I think folks might have some of the materials already, right? Okay, so let me show, if you have the pipe cleaners, I'm gonna model how to make a connector, okay? So it's also in the pictures, but I'm going to just stop sharing for 1 second. And let me spotlight this so everyone can see it clearly. Okay, so here's your pipe cleaner. Okay, and again, if you don't have these materials, just kind of watch. You're gonna fold it in half. All right, you're gonna hold it slightly under the halfway point, right about there. And you're gonna see it has 1 loop, right? Then you're gonna bring down 1 other loop, hold it in place. So now you have 2 loops. Bring down the other side, hold it in place. You have 3 loops, and so that the loops stay, you're going to carefully twist them in place. Just be careful because some of the edges are a little sharp. So just twist it in place, make sure it's nice and tight, and you're going to have a 3-sided joint or connector. Okay, see, 1, 2, 3. Okay. I see some of you following along, very nice. Okay, so once you have that, go ahead and find a straw. And you're going to see that you can, if you can pinch down a little bit on the loop, and you go ahead and put it inside the straw, and you're gonna see that it fits pretty snugly. Okay. So now you have another loop, and you can grab another straw. And now you've made an angle. See that? I'll give everyone a second to do that. All right, awesome. So one thing that I want us to try is we're gonna figure out what is a stronger shape. We're gonna make a square and we're gonna make a triangle, okay? So if you have these 2 pieces already, you're gonna need 2 more pieces of straw to complete the square. And you're also going to need 1, 2, 3 more joints or connectors, okay? So why don't we try making our square first, okay? So let's make another connector. Fold, hold it about underneath the halfway point. Bring down one loop, hold it in place. Bring down the other loop, hold it in place. And twist all of them together carefully. Watch those edges because they are sharp, like I said. Oop, gotta fix mine. All right, so now I have another connector and I'm going to put it on this straw and connect another straw next to that. Okay, so now I have three sides, and I'm gonna finish this side as well, so I need 2 more connectors and 1 straw. So I'll give everyone a chance to do that. Now, if you don't have the pipe cleaners, let's say you have the clay or the tack or the Play-Doh, what you're gonna do is get a chunk of that and make like a little ball, and you can stick the straw like that, and you're gonna make that square shape, which means that you have to make that 90-degree angle. Go ahead and put another straw there, and then you would do that for the other corners as well. If you don't have the clay and you have paper clips, what you're gonna do is take your paper clip, carefully unfold it. Notice that there are 2 loops. If you have the small paper clips, this might work a little bit better, but mine are pretty large. It's all I had. So I'm gonna push, kind of like squish it a little bit to make it small enough to fit the straws that I have. So it's gonna kind of look like that. And you'll notice that you can put the paper clips, they're small enough. You can put it, actually, let me do this side better, through the straw like that. Then you can connect the next straw on the next loop, and then you can finish your square. Okay, so I'll give everyone a chance to make their model, and I'm gonna finish mine. Okay, so once you have the square, everyone, I want you to make another one that is a triangle, okay? So you're going to need 3 straws for that, and you're going to need 3 connectors. So you can make it out of pipe cleaner, you can use the clay, or you can do the paper clip. So go ahead and make your triangle. Here, cool, very nice. Okay, so once you have those 2 shapes, what we're gonna do is we're going to do a strength test, okay? And that's a very, very simple test. All you're going to do is push the corners of the shape, and we're gonna see which of these 2 are more stable.
This is unmuted. This is, no, it doesn't have to be. I just want to know.
Okay, so go ahead and push the corners of your shape. All right, so what have we noticed when you compare both shapes? What have you noticed?
The triangle is sturdier.
The triangle is sturdier, right?
Yeah.
How many people agree with that? Give me a thumbs up, or
I
you
agree.
can do virtual, you can do hand. You agree?
We agree. Very nice analysis.
Okay, and what happened when you did the strength test with the square?
It was awful.
Why was it awful?
Well, the joints were at the right angles, were not as strong. They were flexible and they were not as sturdy as the shape of the triangle.
Excellent, excellent. So you'll notice that it kind of buckles, right?
Yes, buckles.
Kind of this way. Okay. All right, great. So, all right. So I'm going to let's talk a little bit about what happened. Okay, so we did our strength test. And we noticed that triangles were a stronger shape, okay? So why is that? Well, we have different forces involved when we're putting pressure on the corners. So for example, when you're pushing down, you're compressing it, and there's tension happening. Sorry, my cat is, appearance is always. So the compression, right, as you're pushing down, and then the tension comes off into the side. So what's interesting is that with triangles, there is a balance in those forces. So you're going to see that the edges are kind of like fixed and more stable. Whereas with a square, when you compress it, when there's compression, it actually buckles. There's an imbalance of those forces, okay? Now, who knows, and I have some examples on the bottom to pick from. Does anybody know what is a three-dimensional square? You can write it in the chat, you could raise your hand, you could speak.
A cube?
A cube?
A cube, excellent. It is a cube. And does anybody know what is a three-dimensional triangle with the base that we've created?
Pyramid?
It is a pyramid. Now we have a few options of pyramids in our graphic here. Which one do you think it might be from the options there?
Andrea says square base pyramid in the chat.
Square base pyramid, okay.
Yeah.
Any other guesses?
We've got cone from Jeremiah.
Oh, maybe a cone, okay. Well, one thing that I want you to look at is the bottom, the base of the shape.
Lester says, triangle base pyramid, and Michelle says prism, and then I'll let you talk. Sorry, there's just guesses coming.
No problem. Great guesses, everyone. Great guesses. So those were all, some of them were close, but what I want you to think about is that the one we made has three sides, okay? The cone has like one circular side, so it might not be the cone. The square base pyramid actually has a square base, so it probably is not that one. The prism has four sides as well, kind of like a rectangle. So it might not be that one. It's actually a triangular base pyramid, okay, which has three sides, okay? So what we're gonna do, let's just see real quick, is we're gonna add to our two designs and make them three-dimensional, okay? So what you're gonna do is add straws, for example, for the square, add the straws that you need to build up into a cube, okay? So you're gonna need a few more straws, you're gonna need a few more connectors, and I want you to do the same thing with the triangle to make it a triangular pyramid. Now, if you have the clay or tack or Play-Doh, you're gonna try your best to stick another straw going up from it so that you can build up to a three-dimensional shape. If you don't have enough clay, try to add to the ball to give it more surface area. The tricky thing is if you didn't have any of those materials and you just had a paper clip, it might be a little bit difficult to go three-dimensional. Maybe if you have a little bit of tape, you can try it with tape to kind of reinforce and build up, okay? So that's one of the reasons the pipe cleaners are really one of the best materials to do this activity with for when you go three-dimensional, okay? So I'll give you all a few minutes to make your three-dimensional shapes. All right, and I'm going to quickly make mine as well.
We have a question in the chat about how long do you think this lesson would take in reality with youth?
My experience, my suggestion is for you to break this up into 2 sessions at least. The first session, you can do your introduction to like minerals, for example, the way we did, and make the shape test, do the shape test with students. If you have time, you can get to the 3-dimensional part, but at least you could do the 2-dimensional. Then the next session, you can build 3-dimensional and then launch the design challenge. If you wanted to do 3 sessions, the kids can improve their designs and retest. So I would say ideally 2 sessions, 3 if you want to go a little bit more in depth in the design process. Okay, so I'm making my cube here. Okay, so here's an example of the cube. Okay. If you have it, just hold it up. I think Jocelyn, you made the pyramid. Very nice. And the cube. Wow, you're fast. Excellent. Pyramid, beautiful. I love the colors. So once you have your 2 shapes, go ahead and do that strength test again by pushing those corners. And let's see what happens. Okay, so what do we notice? Now that we have 3-dimensional shapes, did anything change?
It's bending more for the square, for the
Which
cube.
one's bending?
The cube.
The cube, okay. Okay, so I think that's definitely something that we're all noticing, is that yet again, the base of a square or the cube is buckling, okay? And I think with the pyramid, it's a lot more stable, and
It's sturdy.
we're a little bit, it's definitely more stable and stronger. As we know, the reason why the triangle is a stronger
Doesn't
shape
budge.
is that balance of tension and compression, okay? So what does this all have to do with the mineral discussion that we had earlier? Well, let's find out. Okay, so what I'm showing you right now are some of the crystal structures that make up some of the minerals that were higher up in the hardness scale. So quartz, topaz, corundum, and diamonds, for example. And what's interesting is they have something in common. They have something called tetrahedron shapes, okay? And basically what that is a triangular pyramid, okay? Not the square pyramid, the triangular pyramid with the three kind of like ends on the bottom. So it makes sense that these minerals will be higher up in the hardness scale because of their crystalline structure. Okay, when you really look closely at how the mineral is made up with certain technology like X-ray something or other that geologists use, they're able to kind of see this crystalline structure. And the shapes, what they have in common is that they're tetrahedrons. So that's why they're more stable and stronger. Okay, so that's how it ties back to the minerals. Okay, now we're not going to have time to finish the design challenge, but what I want you to do is take a look at what all this experience leads to. Okay, so you do the mineral introduction, you play around with the shapes, you start off with 2-dimensional, you build up to 3-dimensional. And then you would launch a design challenge to put all that information together in a fun way. So here's what the lesson you're gonna get, the prompt for the design challenge. So the prompt is to create your own mineral structure made up of geometric shapes that is as strong and stable as possible. Now, the way that students would test their design is by whether or not it would support something like a filled up water bottle. There are other things you can use as well, like wooden blocks or maybe like a textbook. But if they're doing this at home, I think a filled up water bottle would probably be the easiest thing to test it with because it's the most accessible thing, okay? Now, the materials that we suggest for best results, like I mentioned before, are straws, the pipe cleaners, something like a disposable plate, something simple like this. And masking tape is optional, okay, to kind of secure parts as they see fit. Now, one suggestion that I often use, especially if I'm a little bit tight with time, is rather than the kids start from scratch, which they could if you have more time, but if you don't have that much time, what I have them do is start with the cube that they made, which obviously is very weak and it's not going to hold the water bottle, and figure out ways to make this shape more strong and stable. Okay, so they can tweak things around, they can add things, they can cut straws, they can whatever they want to try with their design. So this is kind of like their starting point. And one of the things that I remember Sue did before with the square was to cross brace it, and she made those 2 triangles, if you remember that. So cross bracing might be a great strategy to add to some of the sides of the cube in order to strengthen it. So that can be something that the kids try. The way that they would test it would be, well, this plate is a little small, unless they have a cross brace here. You could probably use a standard size paper plate, but the idea is that the plate would go on top and then the object with the weight would go on top of that. And the goal would be that your structure does not dismantle, fall, and just kind of like collapse, that it kind of stays stable and strong. Okay, so that's the design challenge. That would be the next step for this experience.